3.
Bonding in chemistry.
Bojangles.
Hannah.
RJ.
Jax.
Today we'll be covering facts, information, and lessons to help you become a master at bonding in chemistry. Chemistry is the study of matter and energy and the interactions between them.
We will start off with electron configuration and its relevance to bonding. Electron configuration is the distribution of electrons of an atom or molecule in atomic or molecular orbitals. The two different types of bonds are known as ionic and covalent bonding. Even in covalent bonding, which does not involve ions, the configurations of electrons in two atoms are very important.
However, because of the behavior of electrons cannot be fully predicted, this distribution can only be expressed in terms of probability.
Picture this. An electron moving around the nucleus of an atom can be compared to a fly buzzing around food at the center of a sealed room. We can state the fly is in the room and he's probably in the center, but we cannot predict his location at any given moment. In the picture right here, you see the orange circle represents the room, the apple represents the food, and the black almond represents the fly flying around it.
Now that electron configuration is clear for you, let's touch up more on ionic and covalent bonds. Ionic bonds, which occur when a metal bonds with a nonmetal, are extremely strong. The ionic bond that occurs between elements occur from the attraction of opposite charges. A covalent bond, on the other hand, is a chemical bond that comes from the sharing of one or more electron pairs between two atoms.
An example of ionic bonds are used to salt the roads for the winter because they lower the freezing point of water. Alright, an example of covalent bonds is H2O, which is commonly known as water. Without it, humans could not survive.
Covalent bonds are also known as intermolecular forces. They are inside the molecule and hold the atoms together to make the molecule. The attractions between molecules are called intermolecular forces.
When having the problem not knowing which does what, always think covalent is sharing and ionic is attracting.
What significance does this have in chemistry? Your answer is the goal of 8 valence electrons. German chemist Richard Abegg discovered the method of 8 valence electrons.
Abegg hypothesized atoms combine with one another because they exchange electrons in such a way that both end up with 8 valence electrons. This way was an early model of ionic bonding.
How was the valence electron method displayed? The Lewis dot structure helped Gilbert Newton Lewis develop the Lewis dot structure. This was just a means of showing schematically how valence electrons are arranged among the atoms in a molecule. This is the steps for drawing a Lewis dot structure for a covalent compound. This is carbonate. So in the example of CO3, 2 minus, you're going to have carbon has 4 and each oxygen has 6. Add 2 for the -2 charge, so it's going to be 4 plus 3 times 6 plus 2. It gives you your 24. Then step 2, you draw the Lewis dot structure itself. And with the central atoms in the middle and the other atoms around it connected with a single bond, so that'd be your oxygens connected to the carbon. And then step 3, you add 6 more electron dots to each atom except the central atom. So that's shown right here. And you just keep the central atom alone by itself. And then any leftover electrons are placed on the central atom. You find the number of leftovers by taking the total from step 1 and subtracting the number of electrons pictured in step 3. So 24 minus 24, it gives you 0 leftovers because when you add all those up, it's going to give you 24. And then step 5, if the central atom has 8, then you are done. If not, move 2 electrons from a different atom to make multiple bonds. Keep making multiple bonds until the central atom has 8 electrons. So down here, we have a total of 4 electrons shared here. And then 2 electrons removed to form a double bond. And that gives you your 1, 2, 4, 6, and 8 on your central atom. So therefore, you'd be done.
As you can see on the whiteboard, this is our football field. We have the offensive line, the defensive line, and this is the line of scrimmage. We have a center, 2 guards, and 2 tackles. The football field represents the molecule, and the offensive and defensive lines represent the atoms inside. I want to bring in double nickel RJ Wilson to explain the relationship between the guard and the defensive tackles.
Alright, as you see right here, this is the guard, this is the defensive tackle. And they both collide together with each other in order for each team to get their job done.
The relationship between a guard and a defensive tackle is a real-life example in chemistry, the way valence electrons are to a Lewis dot diagram.
We out.
This sums up our video over bonding in chemistry. Credits go, Jackson Janes was in charge of the research for the project. Hannah Scoldren provided the whiteboard and materials to get the project done. R.J. Wilson wrote down the script and the words that we used in the video for factual information, and Mary Catherine Francis provided also extra materials and video work, as well as filming most of the things. And this ends our project. Thank you.